Finally, we're working. Okay, so you missed what we've done so far. This thing wasn't working, so we went through and we did 3, where it was 440 complete vibrations in 0.5 seconds. And so they asked us to get omega and period. And so we went 0.5 divided by 440. Now you can tell by looking at your units, your period either has to be 440 divided by 0.5, which would be 880, which makes no sense. 0.5 divided by 440. We know we have to have a number less than 1 if you have 440 complete vibrations in a half a second. So we get this tiny number, and then we did our omega, which is 2 pi divided by the period, and now we're doing 5. So you should just write this down because we're going to do some corresponding even ones, and then just read 5 to yourself. So 5 is another, 5 is our first 2.1. They're asking you the period to go from 0 to negative 1.8. I told you the amplitude. And they told you the frequency. So from there, frequency, you can get your period. Once you get your period, you can answer the question. Show me when you get your answer. Does anyone have it? Bless you. In order to answer the question on the time. In order to answer the question on the time, you're going to have to first get the period. But that's not the answer to the question, right? The period helps you figure out the answer to the question, but it's not the answer to the question. So show me if you're done. Period. You don't have to do all that. You just have to think about the question. We're working with 4 hertz, so it's easy to get the period. The question is, How long does it take to go from 0 to minus 1.8? Just draw your cycle. Draw that cycle. Draw one cycle of your sinusoid and put in the period on that complete cycle. And then tell me the time to go from 0 to negative 1.8. Your sinusoid. Draw one cycle of your sinusoid. Put in the period. Okay, that's the period. Draw one cycle of your sinusoid. Just take your fingers. Draw one cycle. So just start and end at the same point. The full cycle. Full cycle, you return. Full cycle, it starts to repeat itself. This full cycle would be like this. Or you could come in this way. So for a full cycle in a sinusoid, you can go one of two ways, because they didn't tell us which way it was displaced first. You either go like that, or you go like that. Okay, that's one cycle of the sinusoid. Put in your period, and then tell me the time that they asked. Okay, so let's just erase this, right? Have one cycle. Okay, so what's the time? Period is the time for one full cycle before it starts to repeat itself. So therefore, the period is this right here. It's the time for one full cycle. And the period is 1/4. So we have 0.25 seconds is the time for one complete cycle. Now answer the question. Is the time for one complete cycle. We want to know the time that they asked to go from 0 to negative 0.18. Okay, so that is the time. This is positive 1.8. This is negative 1.8. Show me if you have it. Okay, good. That's it.
Wouldn't that depend on like?
Okay, so from going from here to here was 1/4 of our cycle. Going from here to here was 1/4 of the cycle. Going from here to here was 1/4 of the cycle.
Oh.
So to go from 0 to negative 1.8 is 1/4 of the cycle. So it's 1/4 of this. Okay, we started out.
I thought when we were in the cycle, I thought it was just one of the first bit, like half that bit.
It's 0.0625. Is that what you had, Violet?
Yeah.
Okay, good. You got it? It's 1/4 the cycle. Everybody understand? Let's go to 7. Tori, can you please read 7?
A 2.4 kilogram ball is attached to an unknown spring and allowed to oscillate. Figure 14.7 shows a graph of the ball's position x as a function of time t. What are the oscillation's period, frequency, angular frequency, and amplitude? What is the force constant of the spring?
They give you the graph. This is like on the AP test, okay? You're picking out the period. That's not hard. I just went through that in that figure right there. You're picking out the period. From the period, you know how to get frequency, omega, amplitude. You can easily get from the graph. Even in pre-calc, you pick the amplitude off that graph. And then from there, you use your equation to get your force constant. Okay, let's see you do that. Show me when you get your period, because if you get the period wrong, then everything else is wrong. You can read from that graph the time for one complete cycle is 0.8 seconds. So we just went through everything in 5, doing 1/4 the cycle. If you just read on that graph the time for one complete cycle, you should see that it's at 0.8 seconds. Once you get that, you can get all the others. Just using your equations, it's not that hard.
Is this right?
Okay, that's right. So just getting the reciprocal. So our period and frequencies are reciprocals. And 1 over 0.8 is 1.25. Amplitude is always positive. It's the absolute value.
Absolute value, okay.
Okay, so we have 2 pi times the frequency. We get 7.85 radians per second. Then you just read the amplitude from the figure. You take the positive. Your amplitude is just the deviation. Connor, do you have the amplitude?
I do not.
is just the deviation. What's the deviation here? Okay, from there, you're getting your period of this as a spring. You should have an amplitude of 3.0 centimeters. Put your units in. Then show me if you have your last period. They asked you to get the K. Remember your units for K? You know the period, and so it's easy to get the K. You have your equation for period of the spring. You wrote it down. So on the orange card. Show me when you have your K. So we have our equation. The period is equal to 2 pi square root m over k. So you have to square both sides of this equation to isolate your k. So you get period squared 4 pi squared m over k. Then you isolate your k. Okay, so you move up your k. You should get a pretty big number over 100. So 4 pi squared times m, 2.4, divided by 0.8 squared. It's going to give you a pretty big number. Thinking, do you have it?
Is K 148.04?
Yeah. 3 significant digits, it's 148 newtons per meter. Okay.
Do we need to solve for F or this?
No, we're done. That was just the question is what is the force constant? That's it. K is your force constant for the spring. Okay, we're going to do 9.
If it was asking for F, what would it be like? What would
It'd
it
be K times X. It'd have to be for a particular, they'd have to give us a distance. I'll read 9. When a body of unknown mass is attached to an ideal spring with a force constant 120 newtons per meter, it is found to vibrate with a frequency of 6.00 hertz. Find A, the period of the motion, B, the angular frequency, C, the mass of the body. That's not a hard question. You should like these questions. You're just working with those same equations over and over, plugging it in and solving. This is easier than your gravitation equations.
I don't agree.
It's just those three equations, period, frequency, and omega. So they give you the frequency. They ask you for the period. That's easy. Show me when you're done. Show me when you're done. You should get your period very easily. This is not a hard question.
Is the mass going to be a small number?
What?
Is the mass going to be a small number?
They asked you for the period and the omega. Oh yeah, see. It's pretty small. Let's just go over A and B first. So for A, your period is 1 over the frequency. So we have 1 over 6, we get 0.167. B, your omega, is 2 pi times the frequency. So you have 2 pi times 6, which is 37.7 radians per second. Now that stuff was so easy. You're just using those same three equations. Now they ask you to get the mass, but you have your equation for a spring. You've written it on the board so many times. You can use the period of the spring, or you can use an equation for omega to get your mass. You know the period for the spring, just plug in and you're going to have to square both sides again. Isolate your M. The period is 2 pi square root M over K. It's the same thing we were doing before, but this time you're getting M. Did you isolate M in the equation?
I did.
So just like before, we have T squared is equal to 4 pi squared M over K. This time you're isolating the M, so you move up the K, you move this down.
Okay, so what I had was 2 squared times K over 4 pi squared.
Did you put this in parentheses?
I think I did.
Yeah, I had the same problem. I didn't put parentheses.
You should get a number
I've already
Yeah, pencil, then lead. Yeah, all big.
So we isolate m, right, in this equation, so we get period squared k over 4 pi squared.
So does K stay in the final answer?
Oh, let's see what I did.
K is right here.
I think I saw it wrong. I didn't square my t. I times it by 2. That's
Okay, so we have this. Another equation you could have used is omega is equal to square root k over m. So omega squared is k over m. That one's a little bit easier, but anyway, it comes out the same in the end. Either way, you should get 0.0844 kilograms. Is that what you got? Did you get that, Tori?
I'm not a pencil lead, so.
0.079.
I got a spare pen.
Did you use 37.7? You might have just rounded that. Okay, so for homework, I'm going to give you 2 through 10. Now, I'll go over these on Thursday because you have to study for your math test. So if you have time today, you can do it. If not, I'm not going to check it for grade until Thursday.
I think I'll get Arrowheads.
Yeah, what?
Golf tournament again.